Hi everyone, this video is on ideal gas law. Um, Ideal gas law. We have talked about Boyle's law, Charles' law, Gay-Lussac's law, and combined gas law. And when we discussed those laws, we talked about that there are four variables when we study the behavior of gases. We have temperature, pressure, volume, number of moles of gas. All right, so when we studied those gas laws, we kept two of the four variables constant and studied the behavior or response of the other two variables. Like for Boyle's law, if I, just as a review, we kept temperature and number of moles constant. Okay, temperature and number of moles constant. Um, and we studied the relationship of pressure and volume. P1 V1 equals P2 V2. For Charles' law, we kept the pressure and number of moles constant, and we studied the relationship of volume and temperature. For Gay-Lussac's law, all right, for Gay-Lussac's law, we kept the volume constant, and we studied the relationship of pressure and temperature. But in the ideal gas law, we are going to change all four variables. And how can we manage to do that? Because it is ideal gas, it is not the real gas. So since it's an ideal gas, I can just imagine whatever it wants, and it should, behave accordingly. So the equation for the ideal gas law is PV equals nRT, where of course I'm sure I don't have to mention that the P is the pressure, V is the volume, N is the number of moles. Okay, this is not something we learned before. So N represents number of moles. All right, T represents temperature, and we must understand the temperature got to be in Kelvin scale. And R is constant. It is called ideal gas constant. And the value of R is different based on the value of or unit of the pressure. If the unit of the pressure is in kPa, okay, your R is going to be 8.314. Because if I want to calculate the value of R here, R will be equal to PV over NT, out of this equation. If I want to calculate R, R will be equal to pressure, volume divided by number of moles and temperature. So the unit for the R is going to be, let's assume that pressure is in kPa multiplied by the liters. The volume is going to be in liters, and this is moles and Kelvin. So this whole thing is a unit for the R. So if in this unit I change the pressure, okay, to atm, the value of R will change to 0.08312, So the value of R will change. Sometimes this value is given to you, when you're working on it, this value is given to you. And sometimes you have to remember that what is the value of R based on the pressure. So all of this is explained in this ideal gas law. PV equals nRT, price, pressure, volume. The volume got to be in liters. Keep that in mind. N is the number of moles, R is the ideal gas constant, and T is it Kelvin. So R value, as I was telling you, if the pressure is in atm, the R is going to be 0.0821. If the pressure is in kPa, the R is going to be 8.314. So this is how it changes. So let's do probably, you need to do this practice in the class. The next thing we want to talk about is the gas stoichiometry, or the volume of a gas. So we have learned this before, that according to Avogadro was the scientist who gave us this relationship. According to Avogadro, 1 mole of any gas at STP, which is standard temperature and pressure, it takes a volume of 22.4 liters. So 1 mole is equal to 22.4 liters. Okay, we have learned this before. So what is the volume of 12.5 moles? So we start with 12.5 moles, and 1 mole is 22.4 liters. Moles get cancelled. You multiply the two numbers, and you got your answer. So that's all it is. That 1 mole equals to 22.4 liters. So let's see how can we apply this in the stoichiometry. So here is a chemical reaction where iron 3 oxide solid is reacting to carbon monoxide gas to produce solid iron and carbon dioxide gas. So the question says determine the number of moles of carbon, the number of moles of carbon dioxide. So I need to calculate X moles of carbon dioxide that will be produced from the reaction of 112.5 grams of iron 3 oxide. So if I have 112.5 grams of iron 3 oxide, how many moles of carbon dioxide will be produced? So again, it's a gas. Okay, so when it comes to the gas, I need to apply the the molar ratio, and the if it was talking about volume, I would have applied 22.4 liters. So I start with what I'm given. Okay, I am given 125. This is not right. I'm given 112.5 grams of iron 3 oxide. Convert the iron 3 oxide into moles. This is the molar mass, and then apply the molar ratio of iron 3 oxide and carbon dioxide from the equation, and that tells you the number of moles. So that's it. That's all this stoichiometry is about. It's the same back. The topic that we learned in last unit. So that's all the stoichiometry is about, and we need to work on these questions, and that's about it. All right, so we will do all the practice in the class. So that's all in this video. That completes our chapter. So I'll talk to you guys later. Thank you. Bye-bye.